look at my paper because I don't want to be, as soon as you just visually see that I circled one, then I'm in the troposphere, the lowest level of the Earth's atmosphere. So right now we know that the lowest level is called the troposphere. The temperature decreases as one progresses straight upward. So we know going from the troposphere up, we know that the temperature decreases as you go upward. At the top, the air temperature ranges from minus 60 degrees Celsius over the poles to 85 degrees Celsius. So between the two poles over the equator, you have minus 50 and minus 85.
So essentially the higher you go, the colder it gets.
Right. So how did I do this one? So we have, I think I put troposphere here. The equator goes east and west.
Here we go. We have our equator.
I only know because I actually stood on the equator line in South America. So that's the only reason why I actually know it.
Yeah. Okay. So if all of this is true, what must be true? So essentially we're decreasing as we get up to this point where the stratosphere starts. And once the stratosphere starts, as you continue going up, you increase.
Which logically doesn't seem right, that the higher you go, it gets colder, but then all of a sudden you get warmer.
Right. And so why? So the stratosphere is warmed. This part is warmed by ozone.
Right. And it's warmed by what's coming from the top. So what's coming from the middle is making things cold, and what's coming from the top is making things warm. So all of a sudden, when the two kind of connect, whatever is above that line gets warmer. If I were to do a visual in my head.
Okay, so when an ozone particle absorbs a dose of ultraviolet sunlight, heat is generated. So what I'm assuming the answer is going to be is there must be ozone, some type of ultraviolet sunlight happening here.
Right.
That's causing these ozone particles to absorb and heat be generated.
Right. So the ozone layer particles are being absorbed somehow above the stratosphere.
Yes. Excellent.
Above the stratosphere.
All right, so start with A.
So now that we completely understand what we're talking about, which
now
is
that
not
we could be scientists.
Good, because this is not how I read this the first time. The first time I was like, oh, forget it. Okay, so if the statement above are true, which of the following also must be true? So it's a must be true question. The troposphere over the poles is thicker than the troposphere over the equator. No.
I would cross that one off because I'm like, I have no idea about what thickness means.
No, I don't know what thickness means, and I'm looking the equator. That doesn't matter because it doesn't matter. We're talking a globe, and they're talking poles, north and south. They're not even talking east and west. So out. Okay, it is warmer at the top of the stratosphere over the poles than it is at the top of the stratosphere over the equator. Again, I would think that would be eliminated for the same thing that we're dealing with a sphere.
Yes, if this said what's the other one? The troposphere, it would be right. But since this is stratosphere, we have no idea.
No, and I keep visualizing a globe versus a circle.
Yeah.
That makes sense? Okay. Mm-hmm. The temperature in the middle part of the stratosphere over the North Pole is at least as great as the temperature in the middle part of the stratosphere over the equator. I would put a question mark there.
Okay.
I need to think that one out a little bit. Okay. The temperature at any point at the top of the stratosphere is at least as great as the temperature at the top of the troposphere directly beneath that point. I'd really like to cross that out because I think that it is irrelevant, but I'm really not sure.
All right, let's think about it.
Let me see if we can eliminate. Let's see if we can eliminate E, or if E makes total sense. So hold on.
Okay, I like that.
So depletion of the Earth's ozone layer would increase the air temperature in the stratosphere and decrease the air temperature in the troposphere. radiation. I kind of like that answer.
But I thought it was the ozone particles that cause the heat to be generated. So how would depleting it?
Oh yeah, you're right. Oh, see, now this is where I'd have to be careful to go back. All right, so cross out E. Because we want the ozone layer. Because it's what absorbs the sunlight to heat the generator. Okay. All right, so let's look at C. Okay. The temperature in the middle part of the stratosphere.
So here.
Over the North Pole is at least as great as the temperature in the middle part of the stratosphere over the equator. I don't know if that's really relevant, to be honest.
Does this temperature have to be as great as this temperature? I don't know how we would prove that.
Yeah, I don't either. So then I would look at the temperature at any point at the top of the stratosphere. Okay, so we're looking at it globally. Is at least as great as the temperature at the top of the troposphere directly beneath that point. God, I hate when they word stuff like this, though.
Okay.
I think it's saying what I want it to say, but I just don't know why they have to make it so complicated.
Right. So does any temperature up here have to be at least as great as the temperature right here?
Well, yes.
Yeah, because we're getting warmer.
Right. All right, so it would be D.
We definitely